Today we are going to find the area of trapezoids. The first note is important. Much like a triangle, a trapezoid can be created by cutting a parallelogram in half. Not quite in a way you would ever think of cutting something in half, but I will show you this is true. We begin with a parallelogram, and I remind you that the area of a parallelogram can be found by multiplying the base times the height. So the base is here, and the height is here. Notice that with our parallelogram, we have two pairs of parallel sides. But we're going to focus on these sides being parallel. And I'm going to say that they're the parallel bases because when I cut this parallelogram in half, I'm doing so from here, you can see this red dotted line, to here. So I'm not going perfectly from corner to corner because that would create two triangles, congruent triangles. And instead, I'm kind of taking that line and scooting it along this little bit, and then I'm cutting here. And that's going to give me two congruent trapezoids. Very interesting, right? Now you'll notice when I cut that, I end up with this trapezoid here. And I left the red dotted line so you would kind of be able to visualize that I cut it and pulled it off. Now notice that when I cut it and I brought it down here, the height remains unchanged. So if I was talking about this parallelogram, the height doesn't change. But remember, what happened to the area when I cut it in half? The area it's decreased by half, right? I have cut the area in half. So I can denote that by saying, well then, this trapezoid is 1/2 the area of that parallelogram. Whatever the measures were, base times height, this is now 1/2 of that. But this is not a triangle. So and the only reason this doesn't work is because I don't have the same base that I had, do I? When I cut it from here to here, I left off part of the base, didn't I? Well, that base, it still exists, but it's the same distance here on this as this here, right? So I lost it here, but it's kind of been put back there. So the base still exists, but now it's in two places. So we can look at our trapezoid and say, well, a trapezoid is a trapezoid because it has one exact pair of parallel bases. So this is one of the bases, and this is the other base. So we'll call them base 1 and base 2. It doesn't really matter which one. But when I add base 1 to base 2, I get the same base, right? This base still exists. This is B1, and this here is B2. This is just relocated to the top of this trapezoid. You may or may not be able to see it, but this is where the formula comes from. So the B here has turned into base 1 plus base 2. If I want the same exact value, I need to now add these two numbers together because they've been split apart when I created my trapezoid. So here's where we're going with the formula. The formula for area of trapezoids is 1/2 the height times the sum of the bases, base 1 and base 2. It doesn't matter which base is base 1 and which base is base 2 because you're adding them together and you'll have the sum anyways. The commutative property of addition says that it doesn't matter. So the area of the trapezoid, here it is in words, is 1/2 the height multiplied by the sum of the lengths of the two bases. Keep in mind that the bases of the trapezoids are the parallel sides. So if the trapezoid looks like this, here are your bases. If the trapezoid is on its side, the bases are, in fact, vertical. That's okay. The height is what's horizontal. And then here, bases are here, and the height would be actually one of the sides because it's perpendicular to the bases. Keep in mind that height is perpendicular to the bases at all times, whether it's vertical or horizontal. It's very important to understand that height is always perpendicular to the base. Okay? So we're going to find the area of a couple trapezoids using the formula, 1/2 times the height times the sum of the bases. So I'm going to just go ahead and fill in what I know using what I have. The 1/2 is always 1/2. The height here is 4, and base 1 is 10, base 2 is 6. So what looked really scary is now very manageable. 10 plus 6 is 16. We're going to multiply that by 4, which we're also going to multiply by 1/2. And again, you can multiply them in any order you choose because of the commutative property and the associative property. So 1/2 of 4 is 2, and 2 times 16 is 32. And we will say that the area is 32 inches squared. All right, notice my work. It's very progressive, it's very logical, it's very easy to follow. I expect the same from you. In example B, the formula, area is 1/2 times the height times base 1 plus base 2. Well, the area equals 1/2, the height here is 11. Base 1 is 15, and plus base 2, which is 19. 15 plus 19 is 34. And then we have 11 and 1/2. Now, I like to find 1/2 of even numbers because it's much easier for me. So if I look at this, I know that half of 34 is 17. So that's going to be 17 times 11. Anybody not paying attention won't know where 17 came from. Way to go, guys. Pay attention, right? 17 times 11 is 7,171,781. Looks good to me, right? The area of this trapezoid is 187 centimeters squared. There it is. Easy as pie. What if I asked you to apply this? Where would we apply it? Here's a scenario. Justin is painting a trapezoidal canvas that is 12 feet tall and has bases that measure 15 feet and 40 feet. If paint is $3 per can and each can cover 15 square feet, how much will Justin spend if he intends to cover the canvas? Sounds to me like we need to find the area first. So we will use the formula. Area is 1/2 the height times the sum of the bases. Now it said it was 12 feet tall, so I'm guessing that that's H. And it says it had bases of 15 and 40 feet. So we add those together. Well, let's see. A equals 15 plus 40, that's 55. So we'll say 55. And half of 12 is 6. So 6 times 55, 330. So the area is 330 feet squared. But normally it would ask me, that might be the end of my problem, but it isn't. If paint is $3 per can and each can cover 15 square feet, how much will he spend? Wow. So if I need to cover 330 square feet and one can covers 15 square feet, I could do this, cans and square feet, and I could say, well, one can covers 15 square feet. How many cans cover 330 square feet, right? So how do I get from 15 to 330? I'm going to do some division just to see. 15, 330, I know that's 2, and that's 30. So that's going to be 22 cans. So times 22 here, so 1 times 22, I'm going to need 22 cans. It doesn't ask me how many cans, though, does it? It says how much will he spend if they're $3 per can. $3 per can times 22 cans, it's going to be $66. And that's going to be the final answer to this question.